wherever you are in any part of the world. The beautiful thing is, all my followers are in different time zone, and I appreciate the fact that I have people from different parts of the world, engaging in this 30-minute book reading. Is really amazing, and I feel so honored. Okay, my name is Henry Onowole, and we engage in an activity or a demand to spend 30 minutes of our time on a daily basis. AI governance, AI ethics, and responsible AI. When we're back on the journey, we selected 4 books. One was AI Governance, a Primer, and the author is Edward Aden. And the second one was AI Governance, Applying AI Policy and Ethics Through Principles and Assessment, and the author is Dr. Darrell J. Carlton. And currently, we are reading a book which is more like an unofficial guide for those that are preparing for artificial intelligence governance professional, and the acronym is AIGP. And the certification is coordinated by International Association of Privacy Professionals. This is the book, and the author is Nicole Joy Elmgart. That is the author of the book. Last time we stopped at page 54, and today we're going to continue on the next page, which is page 55. We've been learning a lot through this daily book reading. You can actually immerse yourself with adequate knowledge about artificial intelligence, most especially from a governance perspective and also from an ethical perspective. And one of the things that we have learned is we've learned how individuals who are AI professionals, how they can help the organization drive ethical approach in the development of AI application. One of the major problem with the use of AI technology or the deployment of AI technology is most of the developers or the owners of AI technology do not have the human society in mind when they develop this AI technology. And what I mean is that this AI technology are not built with the context of ensuring that this AI technology are safe to use, because most of the AI technology that are currently being deployed are actually ways of exploiting the human society, because when we provide our data to those AI technology, those data are being used without our consent, without our approval. And that is why, one of the biggest company that has emerged from China, which is DeepSeek, there has been serious allegation against them utilizing users' data at the back end. Even someone even created a viral video on it on Instagram. The person actually used a technology that is used for, detecting the back end of technology. I think the technology is called Wireshark, which is those who are into cybersecurity should know what I'm talking about. And he was able to show us how the data is being retrieved or collected. Users' data are being collected without their consent, which is not right. And that is why, right now, I heard that some countries in Europe have blocked the use of DeepSeek in their country. And, one way to actually force the government of the day to develop stringent measures towards the use and the development of AI application is when the regular individuals become knowledgeable about what harm or what threat AI could possibly cause, why using artificial intelligence, because when you use an AI technology where you don't know that your data is being used, that means that data is actually available in the public domain. Most especially, there are individuals who provide their confidential information, like personal identifying information, to this AI technology without knowing that this data are being used to train the model, and which is not right. It's like putting the person at a very high risk of, where individuals can take advantage of their confidential information, probably to cause them harm, even though AI has been regarded as one of the biggest innovation in the history of mankind. But at the same time, it comes with a lot of risks, which could actually cause disruption, or which could actually pose some high level of threat to the human society, even leading to the loss of life. We've heard of cases where a young boy who was depressed was chatting with an AI technology, and this AI technology, advised the boy to, to leave the world, and the boy went ahead and I did what exactly the AI chatbot instructed him to do, which was a loss to the family. Yeah, and this is the reason why we engage 30 minutes of our time on a daily basis to have an understanding and grow our knowledge about AI governance, responsible AI, as well as AI ethics. Okay, today, please endeavor to share this live with your friends. Endeavor to share this live on all your active social media platforms, so that we can have other people also participate in this daily book reading. Then today we're looking at page 55, and the title of today's topic is AI Development Life Cycle. This chapter explores the AI development life cycle, offering insight into AI system design, testing, and development. It covers the methodology and best practices used in creating AI systems, ensuring they meet safety and performance standards. This chapter is structured around 4 core competencies of Domain 5, with subsection providing a detailed look at the key performance indicators for each competency. Domain 5 competency. 1. Understand the key steps in the AI system planning phase. Understand the key steps in the AI system design phase. Understand the key steps in the AI system development phase. Understand the key steps in the AI system implementation phase. Section 5.1. Understand the key steps in the AI system planning phase. This section covers the following KPI. Determine the business objectives and requirements. Determine the scope of the project. Determine the governance structure and responsibilities. Embracing a principled approach and nurturing an inclusive, diverse community are indispensable to building a strong culture of responsible AI. The culture is pivotal for navigating the rapidly evolving AI landscape, laying the foundation for a resilient program that rises to the challenge of AI in the early 21st century. We're in page 56. An organization that effectively mobilizes its community to plan, design, develop, and implement AI systems, foster an environment that mitigates risks, and adapt fluidly in changing requirements, programs, and needs. The life cycle of AI development mirrors that of other technologies, encompassing planning, design, development, and implementation. Albert, with some consideration unique to AI. Defining the business problem. Defining the business problem is crucial for guiding the AI development process. This stage involves identifying common challenges and ensuring alignment with organizational objectives. Common challenges: classification, categorizing data into various types of groups. Regression, predicting future outcome based on historical data. Recommendation, generating suggestion or recommendation based on user preference or behavior. Use cases and mission alignment. AI can serve the organization effectively when in use cases align with the mission and goals. To achieve this, consider the following: assessing the organizational mission and goals. Understand the mission of your organization. What is its purpose? What does it do? What are its key goals? Identify gaps where the organization is not meeting its objectives. What area need improvement? Identifying AI use cases. Focus on use cases that align with the organizational mission. Determine how AI can fill existing gaps and contribute to achieving organizational goals. Data readiness. Data readiness is a critical aspect of AI system development, ensuring the quality, accessibility, and suitability of data. Consider the following when evaluating data readiness: data quality and accessibility. Assess whether the data is of sufficient quality to support AI system development. Determine if you have the right type of data to make your AI system usable. Check whether the data is easily accessible and usable. Data suitability. Determine if the current data sets are relevant and sufficient for the AI system need. Assess whether new data sources are required to fill gaps in the content data sets. If you do not have the right, enough, or accurate data, your AI system may not be usable or perform well. Consider whether you need to acquire new data or refine your existing data set to ensure the AI system can operate effectively. Bootstrapping or bagging is aggregating multiple versions of a model trained on random subset of a data can be used to make a model more stable and accurate. Addressing this aspect of business problem definition, use case alignment, and data readiness, organization can set a solid foundation for AI system development and ensure that AI initiatives align with their broader mission and goals. Page 57. Project scope. Prioritizing business problems to address. To establish the project scope, begin by ranking the business challenges you aim to address. The prioritization aids in identifying the initial use cases to tackle. 3 key factors should be evaluated. What problems are you solving and what is the impact? Knowing what are you trying to solve at the outset is critical to the successful planning of any AI system. Assess the potential effects of implementing an AI solution for a specific issue. Consider whether the solution addresses a major concern or a minor inconvenience and the overall benefit to the organization. Efforts. What are the resources required for the AI system deployment, including time, manpower, and technological needs? Evaluate the feasibility of these requirements in the context of your project timeline and resource availability. Alignment. Gauge how the AI system application align with organization objectives and the specific problem it aims to solve. Prioritizing use cases that closely match organizational goals ensure that the AI system implementation drive meaningful outcomes. This methodological approach ensures a strategic focus on use cases that offer significant impact, are visible with available resources, and align closely with organizational goals, thereby setting a clear direction for the project scope. Establishing a robust governance structure and refining the process of transforming data into accountable insight are foundational to AI system development. This section covers key elements of governance, feature engineering, and model development. Governance framework. A clear governance framework is critical for effective AI system oversight. This involves defining the governance framework, outline the roles and responsibilities for assessing AI development from policy formation to system development, confirm that an AI governance structure exists within your organization. Responsibility allocation. Assign clear responsibilities for maintaining and enforcing the AI governance framework. Determine who draft AI policy and procedures, and identify teams or individuals tasked with overseeing AI system development, testing, and selection. Documentation plays a key role in ensuring accountability and clarity within the governance structure. Executive sponsorship. Appointing an executive sponsor to champion the AI system development and implementation is crucial for success. This role involves enhancing project impact and visibility. The executive sponsor helps garner support from various stakeholders to ensure a cohesive effort. Leading organizational change. Effective leadership is instrumental in driving the AI project forward and ensuring cross-departmental cooperation, which is also the same thing as cross-functional collaboration. Feature engineering. Feature engineering transforms new data into a format that enhances AI model performance. It involves improving model performance. This includes structuring data sets to enable models to learn the most relevant relationship between features and targets, curating subset of features that minimize predictive capabilities, and refining AI models for better accuracy and efficiency. Reducing computational costs. Feature engineering aims to streamline the numbers of features, reducing data processing and storage demands, and enhancing computational efficiency to minimize resources needed for model training and operation. Enhancing model explainability. Increasing the interpretability of AI models ensure fairness, privacy, consciousness, reliability, robustness, and trustworthiness. This is especially important when AI decision impact users and society. Model training, testing, and validation. A comprehensive approach to model development ensures effective AI system. This process includes utilization of diverse datasets, Employ subset of your original data set for training and testing to create a well-rounded and effective model. Training data, build the machine learning model. Test data, evaluate the model performance, also refer it to as a corpus. Iterative development process. Engage in iterative training, testing, evaluating, and refining to optimize the model for your AI system needs. Determine optimal setting to achieve desired outcome and continuously fine-tune the model to ensure the best result. Validation against metrics. Develop evaluation metrics early in the system design to validate model and ensure consistent and expected performance. Test the model on new data to check for generalization and alignment with business objectives. The comprehensive approach to governance, feature engineering, and model development ensures that the AI system is responsibly managed, effective, and aligned with organizational goals. Definition: bootstrap aggregating, corpus, entropy, generalization, parameters, training data, test data. Section 5.2. Understand the key steps in the AI system design phase. Implement a data strategy that includes pre-data gathering, wrangling, cleansing, labeling, and applying performance and asset technology like anonymization, minimization, differential privacy, and federated learning. Determine AI system architecture and model selection. Choose the algorithm according to the desired level of accuracy and interpretability. Design phase. The design phase focuses on developing a strategic approach to data handling and model architecture. The following are things to be considered with data gathering for AI development. Data strategy implementation involves gathering and collecting data that is crucial for the AI system success. Key considerations include data quality. It is crucial to assess and ensure the high quality of data being fed into the AI design and the system overall to avoid compromised outputs. Data formats. Structured data. This type is organized and easily categorizable, often fitting neatly into spreadsheet or databases. Unstructured data. This includes data not easily categorized or structured, such as images of fact, which may require additional processing to be used effectively. Examples of unstructured data are maybe data that are extracted data from like social media like Instagram, YouTube. They can be referred to as your structured data. Structured data could be data that contain information about maybe student performance in a particular course or student's grade, score grade in a particular course. Then that could be referred to as a structured data. Okay, let's continue. Where are we? Static or streaming data. Static data that remains unchanged, offering a snapshot in time like historical sales record. Streaming data that updates continuously, such as real-time customer interaction on a website. Data wrangling and preparation, a critical and time-intensive process. Preprocessing data through wrangling transform raw data into a structured format suitable for analysis. This step is essential for ensuring the AI system can generate valuable insight and perform optimally. The 5V of data preparation. 1. Volume. Assess the quantity of data to understand the scope of preparation needed. Velocity. Consider the update frequency of data to manage its flow. Variety. identify the type of data, structured or unstructured, to determine handling method, veracity, ensure the reliability and accuracy of data sources, value, evaluate the relevance and potential of data to achieve desired outcome. Examine tip. Additional method of data preparation include data cleaning. It involves removing inaccuracy, irrelevant data to enhance quality. Labeling. Tagging data to indicate its nature or category. The next page is page 60. Anonymization. Removing personal identifiers to protect privacy, a crucial step given the challenges in fully anonymizing data without losing its utility. Data minimization. Using only the necessary data for a specific application, enhancing privacy protection. Privacy enhancing technology, PETs or PETS. Differential privacy. This method applies mathematical algorithm to data, allowing it to be used for AI system training and analysis while preventing any one individual from being uniquely identified. Example, when a medical research firm add noise to health data to protect individual patient privacy but still allow researchers to drive useful trend. Federated learning. This decentralized approach to AI training allows multiple sources to contribute to a machine learning model without sharing their raw data. Example, in healthcare, multiple hospitals can contribute to a model without exposing patient data to each other, thereby enhancing privacy while still building a robust AI system. System architecture determination. The process of selecting a system model structure, balancing accuracy and interpretability. Example, a financial institution may opt for a simpler, more interpretable model to ensure that decisions made by the AI can be easily explained and audited, reducing the risk of errors or bias. Choose a model based on the desired accuracy and reliability. Consider what the data can review and how it aligns with solving the problem at hand. Key considerations include time constraint and their impact on model training, the need for data accuracy, and the effort required to achieve it. Definition: federated learning pre-processing. Okay, next is page 61. Understand the key steps in AI system development phase. Build the model, perform feature engineering, perform model training, perform model testing and validation. Development phase. This phase encompasses the technical creation of the AI model, focusing on exploratory data analysis, feature definition, collaborating with experts to identify and select key features that will inform the AI model, ensuring relevance to the analysis, avoidance of superfluous features that could complicate the model. Work with the subject matter expert to select the features. A feature is a specific, measurable aspect or characteristics such as height, color, or substance. Feature engineering involves identifying the set of a features most important for the analysis being done. For example, in calculating a credit score, it is not important to know a personal height, but it may be important to know their age. Use the same feature for training and testing the model to avoid inconsistency between the two. Avoid any unnecessary features that you do not need, as it makes testing more difficult and is a waste of money and resources to develop. Model training. Utilizing subset of data, including synthetic data, to train and refine various models. Testing and validation. Evaluate model against established parameters to ensure they meet the desired objective. Test tip, acronym, TEEV. Test, evaluate, verify, and validate. Definition, exploratory data analysis, parameters, and synthetic data. The next page is page 62. 62. Understand the key steps in the AI system implementation phase. Perform readiness assessment, deploy the model into production, monitor and validate the model, maintain the model. Readiness assessment. Deployment is the process of moving the AI system from a controlled development environment to a live operational setting where it serves its intended purpose, such as making business prediction based on customer data. Deployment. Deployment is the process of moving the AI system from a controlled development environment to a live operational setting where it serves its intended purpose, which is making business prediction based on customer data. The deployment process must be tailored to suit the model type, use case, and operational requirement. Consideration for deployment include selecting a deployment environment that aligns with the model need and organizational capabilities, choosing among cloud-based, on-premise, or edge computing solutions. Considering factors like scalability, control, infrastructure investment, data latency, privacy, and security risks. Packaging the model for deployment, often using containerization to encapsulate the model and its dependency, thereby facilitating deployment across various environments and reducing compatibility issues. You know, there are different ways you can actually deploy this model. Some people use Docker, some people use Kubernetes, and you can also use you can also deploy them via the web as well. Okay, what else? Where are we? The next will be expecting the model for real-world interaction, utilizing methods such as REST API or direct application embedding to provide access to system functionalities. Continuous monitoring. Continuous monitoring is an integral part of the AI system lifecycle, initiated before deployment to assess and ensure model integrity. Key monitoring aspects include detecting and addressing deviation in accuracy, investigating irregular decisions made by the model, identifying data drift that could influence model performance. What is data drift? Data drift refers to the change in the data distribution over time, potentially impacting machine learning, model performance, and accuracy. This shift can occur due to various factors such as changes in user behavior, external events, or evolving business processes. When data drift happens, model trained on historical data may become less accurate or reliable, leading to a decline in performance. Model changes and maintenance. As data evolve, the model may require updates to maintain in accuracy and performance. Implement a strategy for ongoing model performance to prevent drift and sustain effectiveness, which involves 1. Continual iteration of the model based on incoming data and performance feedback. 2. Establishing a baseline for measuring future iteration and enhancement. 3. Recognizing that AI systems may demand more rigorous attention than other technologies to remain current and functional. Summary. The AI development lifecycle share phases with other technological development, planning, design, development, and implementation. Yes, has distinct consideration in each phase. From the outset, AI professionals must identify business objectives and intricacies involved in data handling, model creation, and eventual deployment. The implementation phase is critical, requiring a readiness assessment and a comprehensive plan for continuous monitoring and iterative improvement to ensure the AI system remains reliable and effective throughout its operational life. And this brings us to the end of today's book reading. Today we end today's book reading at page 63, and tomorrow we are going to continue from page 64. And tomorrow we're going to look at, or maybe we should just do that now. Page 64 is actually the sample questions based on what we just read some few minutes ago. Okay, let's start with question 1. You can put your response in the comment section. The options are in form of a multi-choice format. Question 1. Which of the following is not a key step in the planning phase of the AI development life cycle? A. Determining business objective and requirements. Establishing a data strategy. Implementing the AI system into production. Defining a governance structure and responsibility. What is your answer? Mine is C. Implementing the AI system into production. That should not be one of the options in the planning phase. Question 2. In the implementation phase of the AI development life cycle, which of the following activities is most crucial for ensuring the AI system's successful deployment? Deploying the model into production, training the AI model, developing a data governance plan, designing the AI system architecture. I'll read the question in question 2. In the implementation phase of the AI development life cycle, which of the following activity is more crucial for ensuring the AI system successful development? Deploying the model into production, training the AI model, developing a data governance plan, designing the AI system architecture. I don't know. This one looks like A or B. I think I will go with the training the AI model is very crucial. Yeah, that is very crucial. If when you train the AI model, the performance of the AI model will determine if you can deploy it or not. Yeah, I'll pick a B. Then the last question is question 3. What is the primary goal of implementing a data strategy during the AI system design phase? To ensure data privacy and security, to apply feature engineering techniques, to facilitate the integration of AI with other business systems, to improve model performance by ensuring high quality data. Yes, my answer will be D. Okay, let's look at the answer. 1 is C, implementing the AI system into production. Yeah, I'm right. And 2 is A. I got that wrong. The answer is deploying the model into production. And the last one is D, to improve model performance by ensuring high quality data. Yep, I got that. Thank you so much, everyone, for joining today's section of our daily book reading. My name remains Henry Onowale. Please endeavor to share this page with your friends, with your family members, with your colleagues at work, on all your active social media platforms, so that our fan base can expand and we can have a wider or broader audience engaging in this 30-minute book reading, since our goal is to help people grow their knowledge and understanding of artificial intelligence with major focus on AI governance, AI ethics, and responsibility. Thank you. Do have a great day.